So another example of your normal distribution. Statements say a sample of 100 dry battery cell tested to find out the length of life produce the following result. So this is about the cell's length of life. So data given, we have the mean is your 12 hours and standard deviation is your here is 3 hours. Assuming that the data is normally distributed, we assume here the complete data is your normally distributed data. So normally distributed, what percentage of battery cell are expected to have life? First part of this question is more than 15 hours. So as say data is your normally distributed, we may convert your normally distributed data into a standard normal distribution. So to convert a variable x, normal distributed variable, into a standard normal distribution variable, that is z, the formula we have is your z is equal to x minus mu divided by sigma. Mu is your mean and sigma is standard deviation. In that we are just shifting the origin of your x variable. If variable is x and its mean is suppose this one, in that case, or in case of z, we just shift the origin of your this y-axis. So we shift the y-axis at your where your mu of x is lie, means at mu your z is equal to 0. Where x is equal to mu, at that point your z is equal to 0. So here x is your we assume that the length of your life of dry cell. So first part is say the life should be more than 15 hours. So x should be more than 50 hours. We are interested to find its probability. So when x is your 15, the formula says if we convert x into z is your x minus mu divided by sigma. So mu is your 12 given here, sigma is 3 given here. So if we put here 15, so it is 15 minus 12 is your 3 by 3 is your 1. So means when your x is your 15, z is your 1 only. So first part we are interested to find the probability when x is your greater than 15, and that same thing means your this is greater than 1. So if you see, this is standard normal distribution table where this is your z variable and this y axis is your represent your probability of your z, and here this is mu for x, but at this point z is equal to 0, and probability should be greater than 1. As 1 is your right side of your this z equal to 0, so we may take any point that is at we consider as 1. So this z should be greater than this 1. That means it cover the area right side of this line where z is equal to 1. This means, and we know that our table is given from 0 to any arbitrary point z. So we may have to do all calculation with respect to 0. So we may assume that here this probability from 0 to infinity, we know that probability from 0 to infinity is 0.5. So we will take this 0 to infinity and we subtract this range from this, that is 0 to 1. That give you a probability of your one to infinity. So if we subtract or we write your this probability z greater than 1 into your probability 0 to infinity minus we subtract the range from 0 to 1, this range. So now we know that this is your standard value, that is your 0.5 for 0 to infinity, and for 0 to 1 you can just see the normal distribution table. You can just see this 1. So 0 to 1 means you're this one, and this value is your 0.3413. So you just put here 0.3413 and you subtract, this is your 0.1587. The probability when x is greater than 15 means life of dry cell more than 15 hours. Probability is your 0.1587, but it asks a percentage from us. So the percentage means we just multiply this by 100, so that give you a 15.87%. Second part of the same question is says the life is less than 6 hours. So when x is 6, here we assume your x is 6. So if you put here 6 in place of your x, so 6 minus 12 is minus 6, by 3 is your minus 2. When your x is your 6. So when x is 6, your z is your minus 2, and you know that the minus 2 lies negative side of this table, where we assume this z is your 0. And at this point, we know that x is your mu. So z minus 2 is negative side of this, or left side of this central line. So minus 2, less than minus 2 means less than minus 2 means left side of this minus 2 is your reason. And we know that the both side, it is a symmetrical curve. So less than minus 2 we may say, or more than 2 we say, is a same area, right? So this less than minus 2, we may write this as greater than plus 2. So now to calculate this reason, this right side reason only, we may use your 0 to infinity, and we subtract from 0 to infinity 0 to 2 only. So this reason we can subtract from the all right hand side reasons. So we use 0 to infinity minus 0 to 2, it should be 2. So 0 to infinity, we know that right side probability is your 0.5. So 0 to 2 we may see from the table only, that is 0.4772. So if you put here, then subtract, it is your probability, required probability, and in case of percentage, just multiply this by 100. And the same way, your third part of this say the life of your cell is your between 10 to 14 hours. So we may check the value of z when x is 10 and when x is your 14. So when you put here this formula is your x minus mu divided by sigma. Mu is 12, sigma is 3, and when you put here 10, that is x, so it is minus 2 by 3, that is minus 0.67. When x is your 14, it is your 14 minus 12, that is 2 by 3. Now it is 0.67. So one value is at the right side, one value is at the left side. So it should be now it is minus 0.672 plus 0.67. So this value lies, z lies between your these two. So you know that the both side your area is your symmetric. So we may say minus a to a. So instead of your minus a to a, we may say your 0 to your 2a, or you say 0 to a, and we just take this as your twice. So as area is both sides same, so we write this as your minus a to a into your twice 0 to a. So now for 0 to a, you just needed to check the table at 0.67. So 0.6 is this one, this line. Corresponding 7 is your something, this one, 0.2486. So you just put here 0.2486 or 7. Here it is 6. So it is maybe slightly typing error, doesn't matter. So don't multiply with 2, it give you a required probability when the life of your bulb is your 10 to 14, or lies between 10 to 14. If you multiply this by 100, it is give you a percentage. So this question is complete now. Now suppose in the same question, it asks, we have the 500, suppose, bulb or your cells. So problem is, how many bulb having like this one, how many number of bulb. So in that case you just multiply your this probability with your number of bulbs, that is total bulb, that is 500. So once you multiply this with your 500, you get your required result, that is number of bulb, right? That is something you are something 248.70, that means you are something put 248 bulbs, because bulb may be full, never it will half. So we consider your left side value only, so that is 248 bulb of life between 10 to 14 hour, when your number of, or you say frequency, is given. One more important example I like to discuss. In a normal distribution, 31% of item are under 45. So it say 31% of item are under 45 and 8% of item are over 64. So you know that always bell shaped curve is normally distributed. It is given, find the mean and standard deviation of your distribution, and table is your data is your normally distributed. So this is your shape of the your normal distribution. Now when this value is less than 50%, and give attention, when this percentage is less than 50%, because we know that your each side we have 50%, this is also 50%, this is also 50%. So if this value is your less than 50%, like in this example, that is 31% of item are under 45. So as 31%, if you count from this side, 31% maybe lies somewhere here. So this range maybe your suppose, we just suppose this is your 31%. In case this is more than 50%, we have to go right side than this region. We should go to the right of this point, center point, if it is more than 50%. So it say 31% item are under 45. Under 45 means at this point x is your 45. This is a table for your normal distribution, and standard form, we know that at center point this is a point where x is equal to your mu and z is your 0. So but here value is given is x only. Now it say 8% are over 64, means a point where 64 is a point where 8% lies right side of that. So we may say this, if we say this is your 8% only, so this is your 8% suppose. So this point, that is your x, is your 64. So this is your 8%. So when you say the percentage, it is 8%. When you say a probability, then this 8% can be written in the form of your decimal, that is your 0.08. Probability of this region is your 0.08 and probability of this region is your 0.31. Now statement says find the mean and standardization. That means we require two equation in which we have unknown variables are your mean and your standard deviation. So we know that there is a relation between your normal distribution variable x and standard normal distribution variable z, which is this one, right? Another thing, we have the one value x is 45 is given us, and another is x is your 64. So one x is 64, another x is your 45 given to us. If we know the value of z at the same point, we get the equation with two unknowns like your this one. We shift your multiply with your sigma to z. From this, if we multiply sigma to left side and mu shift to the left side, we get this one. Now, what is known to us here? Here we know that your probability of your x less than 45 means your this region, this one, less than 45, this one is 31%, and 31% is means your 0.31, it is given to us. So that means your when your x is 45, we assume that we just assume that your z is your z1, right? So we may write this as your, or you may write minus z1 if you like, because this lies on the negative side of your this normal distribution curve. It's your choice, right? So you may write here, you may say z1, we may say minus z1, it's your choice. So it's your choice, right? So you may write z1 here. So this means you are when you zoom here, z is less than 45 when x, then z is your z1. So the probability is your 0.31. So this probability here 0 to z1, or you may write here minus z1, it's your choice. So that's why I say here it's your choice, you may write here z1 or minus z1. Same reason here you say your z1 to infinity. Here it is minus infinity to your z1, so we may write here minus z1 for just our convenience. It's your choice totally, right? So as left side is negative, I write here your minus z1. So the same probability can be written as your probability from your z1 to infinity. And this can be written as equal to, it's given, already given, and it is 0.31. And we know that this z1 maybe lies somewhere here. So like look like this, like, so this is now z1 suppose. Z1 to your infinity, we may calculate this from by 0 to infinity minus 0 to z1. So we may write this as your probability of your 0 to infinity minus 0 to z1. That is probability from 0 to and which already given to us equal to your 0.31. Now we know that this is your 0.5. So as this is your 0.5, we shift this probability part to the right hand side and 0.31 to the left hand side, and after rewriting this we get this as your 0.0 less than z less than z1, and this 0.5 minus 0.31. So this is equal to 0.19. So this is a probability is known to us here, but we are interested in Z. So that's why you see your normal distribution table, and inside the table you check where the probability is your 0.19. So if you search here, so you can see here, this is your 0.1915. So that is difference of your 0.0015. And also if you see this point, the difference, it is also near 2.19, but difference is your 0.0021. So obviously we prefer this one as a less difference is there, but so if slightly variation is there, you can choose as per your convenience. So we choose here Z1 is your 0.5, right? So here the probability is your 0.19 when your Z1 is your, this Z1 is your 0.19, and this Z when X is 45, Z is what? Negative. Sorry. This probability is 0.19 and value is your 0.5. So this is your 0.5. So this is Z1, but actual point is your minus Z1, because when X is 45, your Z is your minus Z1 we assume. So we may write here it is minus 0.5. So if we put the value of X 45 and Z minus zero point 0.5 in your this equation, or you may say this equation, after putting this one we get mu plus sigma, and Z is your minus zero point 0.5, so it is minus 0.5 sigma is equal to X, which is your 45. Now here we get your one equation between mu and sigma. If we have one more equation, if we find out one more equation between these two unknowns, we are able to find the value of your mean and standard deviation as required by the statements. So we have one more reason, that right side. So this reason says that your this reason say again to us that probability of your, so it is here, the probability of your is 8% when X is greater than 64. So you may say here when your X is greater than 64. This probability is already given to us, that is 0.08. And this means when X is 64, we assume that your Z is Z2. We just assume Z is Z2. As this Z is lies right side, you see it is lies right side here, so we may here Z2 only. Right? So we may assume here You zoom when x is 64, then z is your z2, and probability is your 0.08, and that is z2 to infinity, and z2 to infinity can be written as your probability 0 to z and your infinity here. I'm just typing infinity minus your probability from 0 to z2, which is given to us 0.08. It's given to us. Right, and we know that 0 to infinity is your 0.5, so this is your, we shift this to the right hand side and 0.5 to the left hand side. If we do this, what will be happen here? This give you a probability from 0 less than your z less than your z2. This we shift to the right hand side and 0.8 to the left hand side, and 0 to infinity we know that is 0.5 and minus 0.08, which is equal to your 0.42. Right, now we see the table where this probability 0.42 lies. So go to the table. So 0.42, if you see 0.42 is this one, nearly 0.42, and this one also. So if you see here, the difference with your 0.42 is your 007. 0, 0, 0, and 7. And second one, this one is also close to your 0.42, but the difference here is your 0.0008. So both are nearly same. This is a very small difference between these two. So it's your choice which one you prefer. But for the easiest calculation, I think we can choose this one because it is a value is 1.4 and this one is 0 only, right? Else you can go for 1.4, and this one if you go, then you take 1.41. So it's your choice, right? I am taking this one just for the easy calculation. So we may zoom here. You are now, this give us your z2 is equal to 1.4, right? So same equation we just put in the same equation here. So if you put in your same equation here, just a minute please. The equation is here, this one. So here your x is 64 and z is your 1.4, right? So if you write this, we get your mu plus 1.4 sigma and is equal to your 64. Now if you see here, we have the two equation with two unknown, that is mu and sigma. If we simultaneously solve these two equation, solve these two equation, suppose we may subtract second minus first, subtract second minus 1. So 1.4 minus 0.5 is your 1.9 sigma, and here it is 19, I think. And if you divide this, the sigma is your 10. If you put this 10 in your any of these two equation, suppose here we put here 10, so 10 into 0.5 is your 5. We shift this to the right hand side, so negative become positive. 45 plus 5, that means your mu is 50. So mean is your 50 and standardization is your 10. Hope so you get this one. I just give you just slightly recall this. So given to us your less than 45, your data is your 31%, that may say 0.31, and right side your more than your 64 is your 0.08, data is given to us, and we are interested to find the mean and standardization. So we assume this point given is 45 less than 45. So assume at this point z is your z1. You may assume minus z1, it's your choice, right? So but keep in mind your final z at 45 is your z1 or minus z1. So kindly take care of this thing. So similarly, x at 64, we assume here it is z2. So now this probability is given when the probability of this is your x less than 45 is your 0.31. So this we assume is your z1 when x is z. So it is z2 z1. So z2 z1 means we may right side also understand this. It may say is your this z2 your infinity. So we may say it is your 0 to infinity minus 0 to z1. So if we do this calculations, so that is 0.19, and you just see the probability distribution table, check where the probability is your 0.19, and corresponding value of z is called your z1 with respect to your x45. Similarly, you do the same calculation for your 64, that is more than 64. Is given is 8%, that is 0.08. So when x is 64, we assume z is z2. So this can be written as from 0 to infinity to 0 to z2, that is 0.5. Now just rewrite this. We get probability is equal to 0.42, and just check the table for 0.42. We get the value of z2. So now when x is 45, z is your minus 0.5. You just put in a standard formula, that is your z is equal to your x minus mu by sigma. So you put here 45 and minus 0.1, sorry, minus 0.5. Similarly, your 64 and your 1.4. So once you do that, you get the two equations, and you can simultaneously solve these two equations. You get the value of standardization and you get the value of your mean. So which is your required result. Hope so it's clear. So okay, thank you. So I'm stopping here.